All right, 8.2 practice. Let's get in here and let's get after it. So the big thing is you're looking at whether the denominators are like or unlike. And so these first ones look like they all match up. So those are going to be pretty straightforward. So when you subtract the two fractions, the bottom is going to stay the same. So nothing's going to change down there. But on the top, be careful. When you have subtraction, you're really subtracting that quantity. So you have to distribute a -1 through. So on the top, you're going to have x plus 6y. And then that's going to be a -x. And that's going to be a positive 5y. So when I clean all that up, x take away x cancels out. And 6y and 5y, that would be 11y on the top. So 11/18 cannot be reduced, but that 1y on the top and 4 on the bottom, that's going to end up being 11 over 18xy to the third. Because this y to the first is going to cancel out with one of these to give me y to the third. So there's the final answer for number 1. Moving over to number 2, kind of go similar here. The bottoms are the same. So I'm going to have a 6u to the third. On top, this will just be a -6. So looks like I'm going to have u plus 6v subtract 6 all over 6u to the third. And I don't really think there's anything I can do there. I can't factor the top. There's nothing that can be pulled out. So looks like we just have to be satisfied with that. Moving on down, number 3, we have a couple of addition problems for 3 and 4. So those are a little less to keep track of. Bottom's the same, so keep my 30x. On top, that's going to be 5x. And that'll be 6y and -5y is plus 1y. And I don't believe there's anything I can do with that one either. I think we're all set. And if you think you could, like I said, pick an x and a y number and put it in this expression, and then put it in the expression that you simplify it to. And if they're not the same answer, you misapplied a rule. There's no way to simplify it like that. But be sure to ask me in class if you're confused about whether or not you could go any further. Here on the bottom, we have the same, so we're going to keep it x squared y to the third. On top, x plus x, that'll give me 2 x's. I'm going to have a -6 and a -4. That's going to be a -10y. I do believe on top there I can factor out a 2. So I'm going to yank out a 2, greatest common factor, and end up with this. And then on bottom I have the 8. And I have x squared y to the third. And 2 8s, the 2 can disappear. The 8 will become a 4. And I don't believe there's anything else that we can do there. So I think final answer is going to be right here. We're all good. All right, let's go down a little bit more. Again, still in like term category, so let's a couple more. On bottom, I keep the bottom the same, but I'm actually going to factor that. I believe I can yank a 12x out of there, which would be x plus 2 when I pull out a greatest common factor. This is subtraction, so I'm really going to distribute a negative and a plus there. So that's going to be 3x, and that's going to be 1 plus 2. That's going to be a 3. So I kind of have that going on. And let's see what we can do on top here. I can pull out a 3, and that'll be x plus 1. On the bottom, I have 12x times x plus 2. And that 3 12s can be whittled down. The 3 goes into itself once. 12, that would be 4. So I don't think that I can really do much else with that. I'm going to multiply it out just to see. So I'm going to have x plus 1 over, let me see, this would be 4x. And when I distribute that through, 4x squared plus 8x. Yeah, I don't see any opportunities there to cancel out an x plus 1 anywhere. So I think we are good to go. Number 6, keep the bottom the same. Looks like I could factor out a 3r squared, and which will give me 3r minus 4. And then on top, it's minus, so these are going to both change. So r minus r goes away. Negative 6, negative 2, that'd be negative 8. I don't really see any opportunities there. So, I think you could leave it like this, probably to make it match up with like a standardized test. They're probably going to multiply it back out. So that might have been kind of, I tried to factor it. I thought maybe I could pull something out. I think that's kind of good practice to do, but I ended up doing some work for no good reason. But whatever. So we end up with either one of those I think would be acceptable. Now is where we kind of get into the bulk of the lesson. This is where your denominators are different. So I need to come up with the least common denominator. And a couple different ways, you could handle this. 3 and 4n, I could. So the LCM for both, or the LCD, I guess, least common denominator, or multiple, it's the same thing for both of those, would be 12n. That's the first thing that those two can both go into. So I could multiply the tops, both sides, by 12n. I'm going to multiply this side by 3 over 3. And I'm going to multiply this side by 4n over 4n. So that way I'm going to get a 12n on the bottom, because now I have like terms. So this is going to be 20 mn subtract 18. There's my top. And on bottom, I'm going to have 12n here. And then we should try to see if we can maybe pull something out and get something in here to try to cancel with each other somewhere. So I think on top I can yank a 2 out of there. So if I factor a 2 out, I get 10 mn minus 9. And down here on the bottom, I have my 12n. Well, 2 twelfths can get whittled down. That can go into itself once. That can go into itself 6 times. So I end up having 10 mn minus 9 over 6n. So I think that'll be my final answer. 10 mn minus 9 all over 6 times n. Yep, nothing else can be pulled out there. Looking at the top part, there's kind of different strategies. When I look at the LCM here, I'm going to do this one a little bit different. But the least common multiple is, for 2 and 3, the first number those guys go into is 6. And x squared and x, I got to take the highest power. So that's x squared. And then I have nothing and a y squared. So it looks like that's the least common multiple. So I could just multiply by that over itself on both sides. But I don't know. I think what I'm going to do, I'm going to show you how I would do this one, is I'm going to kind of draw it out. 5y over 2x squared plus 3 over 3xy squared. And I'm going to try to figure out, what do I need to multiply each term by to get the other one? So to multiply 2x squared, to get this bottom right here equal to that, I would have to multiply by a 3 and a y squared. And if I do it on bottom, I got to do it on top, because I want to multiply by 1. And then over here on the other side, to make this expression multiply to make that, I think I'd have to multiply by 2x. So kind of come through, and I'm going to clean this up a little bit. So on top, I'm going to have 15 y squared, or y cubed, I should say. Y squared times y would be y cubed over 6 x squared y squared. And then I'm going to add to that, I'm going to have 6x over 6 x squared y squared. And so now my bottoms are the same. So I'm just going to keep my bottoms the same, like we did on the top problems. Then up top there, I have 15y to the third plus 6x. And I believe I could, if I wanted to, up there factor out a 3. There's a common factor up there of a 3. So that's going to give me y to the third plus 2x. Then on the bottom, I have this 6 x squared y squared. And this will cancel with this, but it'll be a 2. And I don't really see any other opportunities here where I can make much happen. Let me just look. I think we're all set. Actually, I made one mistake here. When I factored the 3 out, there should have been a 5 right there. That would give me the 15y to the third. So I think final answer then will be 5y to the third plus 2x. Or you could have that backwards. It doesn't really matter. All over 2x squared y squared. So I kind of missed that 5 in there. All right, let's move on down to number 9. I know some of these I may not have left you a ton of room, so maybe doing some scratch work on scratch paper might be easier for you. If so, just do it in your notebook. All right, so I look at these two. I look at the 4 and the 5. So an LCD, I think is going to be 20 x to the third, because that's the biggest power. So now I'm like, how can I get 20 x to the third? Well, on this side, I'd have to multiply by a 4x and a 4x. And on the other side, I have to multiply by 5 over 5. So 5 over 5. And that should give me 20x to the third on both bottoms. So I do this out, and I get 15x over 20x to the third. And that's going to be takeaway. And over here, I'm going to get 16x over 20x to the third. Bottoms are the same, so I can just keep it the same. On top, 15x, take away 16x, so that's a negative 1x. All over 20x to the third. And I can cancel out an x, because this is a negative 1x to the first. So I can cancel out this x with one of those. And what I'm going to have to do, I'm kind of glad this came up, but what I'm going to have to do on top is when everything's gone, you're going to have to leave a positive or a negative 1. Since there's a minus sign there, it's going to be negative 1 over 20x squared. So I could cancel an x there because there was no addition or subtraction, kind of screwing me up. All right, next one, number 10. 4x and 2y. Well, I'm looking to get over here an 8xy. Actually, I don't even have to go to 8. 4xy would work for those two. I think I could get a 4xy simply by timesing this side by y over y and timesing this side by 2x over 2x. And I think I'd be good to go. So let's get both of our bottoms down here. See what shakes out on top. I'm going to get 3y plus 4x over 4xy. And I just add the tops up. I'm going to put the x term first. And I really can't cancel anything out because I have that addition sign, which kind of messes me up. And I can't really just cancel out part of an addition or subtraction expression. So I think that's going to be as good as we can go. All right, moving on down, number 11. This one's getting a little bit trickier. So I think here what I might do is since I have like addition or subtraction expression, it's a little different than what's up above. So I think I'm just going to multiply like the right by the left denominator and the left by the right denominator. So for instance, over here, I'm going to multiply by 2k over 2k. And over here on this side, I'm going to multiply by 3k plus 9 over 3k plus 9. And that should give me, on the bottom, the 2k times 3k plus 9. So let's kind of work this out. On top, it may be helpful to put parentheses kind of on these things. But on top, I'm going to have 12k plus 36. Add it to 5. So I probably could just do that right now. Add that to 5. Or no, I'm going to leave that apart. My bad. This is one, I kind of got to do like this whole chunk right here. So 12k plus 36 all over 3k plus 9, 2k. I'm just kind of leaving this in here in case there's a good factoring opportunity later to cancel something out. Well, on this side, plus this stuff, well, that's going to be 10k over the same bottom, 3k plus 9 times 2k. And combine the tops, that gives me 22k. So 22k plus 36 all over 3k plus 9 times 2k. And you see, can I factor something out over here? I think I can factor a few things out. Let's kind of break this down and see if something shakes out. So looks like I can pull a 2 out of the top. So that's 11k plus 18. On bottom, I can yank a 3 out of over here to the edge. I can yank a 3 out and have k plus 3. And then times 2k. And let's see what I can do here. Looks like I could cancel out. Basically, I have like 3 things multiplied together down here. I think I could cancel out the 2's. So, and then cleaning this up, it's going to give me 11k plus 18 on the top. On the bottom, it'll just be 3k times k plus 3. You could also multiply that out if you wanted. And, you could write 11k plus 18 over 3k squared plus 9k. Either one of those, they're kind of the same thing, but I don't think there's any other way to break it down because that top is not factorable. All right, moving right along to number 13. Let's see what we can do here. Excuse me. So I'm gonna try to do this one similar to the last one. I'm gonna multiply the right side by b minus 1 over itself. I'm gonna multiply the left side by 6b to the third, 6b to the third. And let's kind of just do, this piece, and then we'll do this piece. And then I do have to be aware of, I'm going to be distributing a negative through the side over there. So that'll change things up a little bit. Let's see what we got. So I'm going to have 24b to the third all over, that's going to be 6b to the fourth minus 6b to the third. Take away, and the bottom is going to be the same. 6b to the fourth minus 6b to the third. And on top over here, when I distribute the 2, I'm going to have 2b minus 1. So 2b minus 1. Now I have to distribute the negative. So when I distribute this negative through, it's really going to change to that. So now I can kind of ignore this negative. I can just kind of combine like terms on the top, which will give me 24b to the third minus 2b plus 1 all over 6b to the fourth minus 6b to the third. Now I could factor that bottom back out, but I really don't see an opportunity on top. B to the third, b's and 1 and numbers, I really don't see a way to factor that. So I think we're kind of about as far as we could get at that point. Let me see if I can maybe break this down somehow. And on top here, I realized I made a mistake. When I distributed right here, I had 2b. That should be a minus 2. But then the negative sign when we distributed it turned into plus. So over here to the right should have been a plus 2. So now I can factor out on the top. I can yank out. A 2 is the biggest thing I can pull out. I'd have 12b to the third minus 1b plus 1. Bottom, I would have, I could yank a 6b to the third out, but I think I'm just going to pull a 2 out. All right, I'll yank a 2 out of that, which will give me, because I want to cancel the 2's out, it'll give me 3b to the fourth minus 3b to the third. And then when I cancel those 2's out, I think that's about as low as I can go, because the top cannot be factored any further. So that could be the answer. You also could, if you want to, just depending on how the book or how the standardized answer sheet, they may factor the bottom now and yank out a 3b to the third and call it b minus 1. They could leave it that way. I don't think it's really important one way or the other. But once you know that the top is done being factorable, there's really no way to cancel anything out of the bottom. All right, number 14, kind of made this a little bit bigger so it's easier to write on. So when I look at this one, you know, I have the left-hand side, and then I have the right-hand side, and I see that in order to get a common denominator, I'm going to have to multiply each side by the other denominator. So I'm going to multiply by an n plus 1 over an n plus 1 and an n plus 5 over an n plus 5. So on the bottom, I now have n plus 1, n plus 5. And on top, let's see what I'm going to get. I'm going to get 5n plus 5. And then over here, a 5n squared and a 25n. Notice it was plus, so I didn't have to worry about changing signs or anything. So when I kind of clean that part up, I end up with on top, that would be 5n squared. That would be plus 30n plus 5 all over n plus 1, n plus 5. Now hopefully I can factor that top out and get something to cancel. I see I can pull a 5 out of there. So that's going to give me n squared plus 6n plus 1, which is not going to be factorable. I was really hoping I could kind of pull one of those people out. And I wonder if, you know, so something else I might want to check is I could try to multiply one of those two bottoms by the top part and see if there's any way to get it to cancel out. Let me just kind of peek at the answer and see if that's possible before I waste a bunch of time going through. Yeah, it doesn't look like it. It looks like basically they just left the top the same way, except for they wrote it in a little bit backwards order. But you know, this right here is pretty much the exact same as this right there. So it looks like nothing was able to factor out. So we're good to go. All right, let's go to the next one. Number 15. Double checking this one. So on the left, we have 6 over x plus 4. Actually, I might be able to just, well, thought maybe I could write it over there, but I'm kind of cramped over on the side. So I think I got to multiply the left by the right and the right by the left. So let's do that. Over here, I'm going to write 5x squared plus 25x. 5x squared plus 25x. On the left, x plus 4, x plus 4. Come over here where I got a little bit of room. So on bottom, I have 5x squared plus 25x, which I realize that could be simplified, but I'm going to leave it, or yeah, could be factored, but I'm going to leave it alone for a second. See what we get on the top. On the top, I get 30x squared plus 150x plus, and then this part would be 5x squared plus 20x. And clean that top part up. I get 35x squared plus 170x. And that's the top piece. And then on bottom, now here's where, like, if you're doing the work, I would look and see, you know, is that as far as they want you to go? I actually think simplifying these fractions are harder than the next unit, which is solving the equations. But when I look at that, I'm like, well, maybe I could try to do something like I kind of see that on the top, I know I could pull out a 5x out of that. So if I pull out a 5x, that would give me 7x plus, what's that, 34x? Or plus 34. Then on bottom, I think I could pull a 5x out of here. 5x, and that's going to be x plus 5, and then x plus 4. And then I do see I can get rid of the 5x's. So cancel those out. And at this point, I really don't see if I can go any further. Let me kind of peek at the answer sheet. All right, and it checks out. There's the answer right there. So that one I was able to factor a little bit further. Keep on going. Number 16. So this one I'm going to try to just smash right in over here. So on this side, I'm going to do an n plus 6 over n plus 6. I'm going to do an n minus 6 over n minus 6. It is subtraction, so be aware of that. So it's going to give me, on bottom, an n minus 6, n plus 6. Which I'm always hoping that's going to cancel later. On top, I have 3n minus 18. And then minus, over here on this side, that's going to end up being 5n plus 30. But remember, when you subtract, you have to distribute that negative through. So really, I'm at 3n minus 18 minus 5n minus 30 all over the bottom. And clean the top up a little bit. I get, when I combine my n's here, I get negative 2n. And when I combine my negatives there, I get negative 48 all over n minus 6, n plus 6. And on top there, I could factor out a negative 2. So that's negative 2, which is just going to be, what, n plus 24? Yeah, I don't really see how that's going to help me. So they're probably going to leave it like this. Let me just double check the old answer key here. And yep, it looks like they just left it like this, and they did not factor that top out any further. Not to say that this one's not right. It just went a little bit further than what they wanted, but you got to be able to kind of look at both answers. Complex fractions, number 17. So these are the keep, change, flip. Remember when you divide fractions, keep, change, flip. So I'm going to keep, I'm going to change, and I'm going to flip. The nice thing about these are you don't have to get a common denominator. You just multiply straight across. So 1 times 5 is 5. M times m plus 2 is m squared plus 2m. And we are good to go. Really can't go any further than that. Multiplying fractions is really nice because the denominators don't matter. So you kind of like it when you get to these ones. They should go quite a bit faster. Keep, change, and flip. And that's going to be 3x on top of, I don't know, I could be lazy and just write it like this. Or maybe I don't see that on a multiple choice test, so maybe they write it like that. Either one of those would be fair game. I think on the answer key, they chose this one. So just kind of be aware. Either one's good. Number 19. Ooh, this one's a little tougher. So I got to keep, change, flip. But then I have this fraction thing on the bottom. I have to do this addition. So this is really x divided by, this expression of 9/16 plus x squared over 3. And I need to kind of take care of that right side and turn that into just a simple fraction. And then I can keep, change, flip. So let's kind of just ignore this beginning part. And let's deal with this parenthesis. So 16 and 3, the least common multiple between those two, I believe, is 48. So I'm going to try to make my bottoms both be 48, which basically means I got to multiply this side by the 16, and I got to multiply this side by the 3. So that gives me 27/48 plus 16x squared over 48. And I can now add those two fractions together because they have a common denominator. So I can say, all right, this is x divided by, and that's just going to be 16x squared plus 27 all over 48. Now I have a fraction, or I have a number divided by a fraction. So I can do the keep, change, flip. I'm going to make him a fraction just so it's a little more normal looking. So we're going to keep, we're going to change, and we're going to flip. And when I multiply the top, I get 48x. When I do the bottom, I don't think I can factor. I don't think there's anything that goes into 16 and 27. Like there's no number I can pull out. So I think I just have to leave it alone. Leave it. And I get that. Double check the answer key. Beautiful. I think they wrote the bottom as 27 plus 16x squared, but same thing. So that one's a little bit trickier. And last problem, Number 20. Holy smokes. This thing looks nasty. So first thing I'm going to do is I'm going to put the top in here. So I'm going to keep the top. And I know I got to flip this bottom, but let's just get after this bottom right now. Let's just kind of ignore this top part, and let's just figure out this bottom. So I think I need to multiply this side by u over u, and this side by u minus 1 and u minus 1. So when I do that, on top over here, like this little piece, so on the left-hand side, I'm going to get u squared minus 1u is minus 2u plus 1 over, we're just going to leave the bottom like it is. And then I'm going to have a minus 2u squared, because that's what that comes out to be. And then I got a u minus 1 times a u. And when I do the top, this got to make that a negative. So combined like terms, this whole blue part is actually negative u squared minus 2u plus 1 over this thing. So that represented this bottom piece, which is just a fraction now. Now I got to flip it. So I got to flip this out. Man, there's a lot of places to go wrong on something like this. This one's pretty tough. So flip it. U minus 1 times u over, and I don't like that negative u squared, so I'm going to pull a negative 1 out. And I'm going to go u squared plus 2u minus 1, which I don't think is factorable. So now I just got to multiply. Holy smokes, this thing gets really messy. Geez, oh Pete's. Let me just combine like this. I'm going to just call this u minus 1 times this other u minus 1. So let's just do that. Times a u. Put it in the front. And then the bottom, that's going to be negative 1 times u squared times this stuff. This is just getting silly. This is just kind of a dumb problem because I don't know if they want me to multiply it out or not multiply it out. I'm going to peek and look at their answer. And yeah, it looks like they wanted me to multiply this whole thing out. So when I do a test or a quiz, I'm not going to put something crazy like this because now it's just kind of becoming busy work. But if I were to multiply the top out, I get u times this part right here would be u squared minus 2u plus 1. On the bottom, that's going to be negative u to the 4th minus 2u to the 3rd. Actually, I might just leave that negative 1 out front for right now and just do the u, just kind of treat it like this. Just do the u squared piece. So u to the 4th plus 2u to the 3rd minus u squared. And then distribute the negative 1 through and distribute the top. Holy crap. I've lost interest in this problem. U to the 3rd minus 2u squared plus u. I owe you guys big time for selecting this problem. Better match the answer. I'm going to be upset. All right, let's see. U to the 3rd minus 2u plus 1. Wonder why. Oh, I see what I could have done. Yeah, this one's rough. So what I could have done is I could have pulled a U out of this bottom piece. So way up here at the top, I could have canceled out one of these U's with one of those U's. So basically it would make him go away, and I would be left with U squared minus 2U plus 1 all over. And if I took a U out of the bottom, I would have negative U to the third. That would be a minus. I lose a U there. And that would be a plus, and I'd lose a U there. Yeah, I'll never give you nothing like that for the quiz or the test. So long, drawn-out problem. I knew looking at it was going to be crazy. Hopefully this helps you with the practice on the majority of the problems. Sorry, some of them took a little bit long. See you.